Hello, I'm Kevin Olson from TextLearn.com, and this is lesson 3.1 of the Intro to Java series, which is available at textlearn.com/series/Java Intro, topic 3.1, which is down there. In this lesson, we're going to be discussing big decimals. What is a big decimal? Big decimals are specialized objects which are appropriate for storing currency values. If you remember the last lesson or the last topic, we discussed primitive data types. Specifically, we talked about the float and the double and how those are not appropriate for storing currency values because of possible rounding issues. So if you have an application that deals with user accounts and money, things like that, it's possible that over time the calculations, if you did them with doubles or floats, would start to have rounding issues and the balances would be off. And of course that would be a terrible thing in any type of accounting situation. So to get around that issue, we use big decimals. So these are what we will be using to store currency values. They are immutable objects, meaning once you create it, its value cannot be changed directly. In order to perform computations, you must use the appropriate big decimal methods to create entirely new big decimals. So once a big decimal is made, it's made and it has that value and it's locked into that value. The only way to change it is to create a new object and essentially change the reference, and we'll get into that in a moment. So to begin, we have to import the big decimal from the java.math class, or the java.math package, I should say. So we'll do that. And then we have big decimal, my decimal equals new big decimal, and we assign a value to that using quotes, and we put the value in there. So it's like a string, really, that we're sending to the big decimal class that will create our new big decimal with that constructor there. All right, so that is how we create a new big decimal. So some of the key methods that we're going to be using with big decimals are, instead of using the traditional operators plus, minus, divide, and equal, we have to use instead these guys over here, the add method, subtract method, multiply method, and divide method. And let's get into that now. I'm going to launch my VirtualBox over here, and let's take a look at all this. I already have the big decimal class open in the Java API documentation over here, and of course that's at docs.oracle.com. You can see the address in my bar up there if you want to take a look at this, and this gives us a full description, a really detailed description of the big decimal class. So the constructor summary and big decimal, here we go, big decimal, and then we are going to be passing it a string value technically, and this is going to translate the string representation of a big decimal into a big decimal. So that's what we're doing when we create the new big decimal with a certain value, and we have those quotes in there. Okay, and some of the important classes or methods that we're going to be using in this class are going to be the add, subtract, multiply, divide, and here's the subtract method, for example. And then we have also the toString method, which is very important. That's going to convert our big decimal into a string so we can display that in the console. Alright, so let me show you some of this. Just bring up my let me bring up my method over here. Delete this part, Kevin. Okay, so let's go into Eclipse. I already have a project created to test our big decimals out, and as you can see, I have imported the big decimal class from the java.math package, and I have my main method down here, so that is ready to go. And let me just clear the console. All right, so let's create a big decimal. So big decimal, decimal 1 equals new big decimal, and then we pass it that string value, which is going to be 10.00, and big decimal, decimal 2 equals new big decimal, and we're going to give this one a value of 5.00, of course end with a semicolon. So now we have created two new big decimals, decimal 1 and decimal 2, and we've given them values. So that is taken care of. Now let's start performing some operations. So let's say we want to add the two big decimals together. Like I said before, we can't just do decimal 1 plus decimal 2. We have to use the add method of the big decimal class. So big decimal, and we have to create a new big decimal to store the result. So let's call this big decimal sum equals decimal 1 plus decimal, oh nope, my bad, dot add decimal 2. So used to doing sums with addition. So what this is doing is we're creating a brand new big decimal. So the big decimal class is actually creating a new big decimal. We don't see the keyword there, we don't need it there, but this is an entirely new big decimal object with the addition result of adding these two decimals together. And that goes back to that immutable thing that I was talking about, where we cannot have a big decimal with a different value. Once we create the value, it is always going to be that value. Big decimal, subtract, I could call that difference if I wanted to, equals decimal 1 dot subtract decimal 2. And I'm using these kind of shortcuts here. If you see, Eclipse has a lot of auto completion features, and that allows us to code a little faster. And let me just show you that again. Big decimal product is equal to decimal 1 dot multiply, and here we have the list that shows up here. So it's saying we can use the multiply method. So if I just hit enter there, it automatically throws that in there for me. And we can also go in here, use the I use the plus, the up and down arrow keys to navigate through this list, and we're going to go with decimal 2, hit enter, and semicolon to end the line. So now we have sum, subtraction, product, big decimal divide equals decimal 1 dot divide decimal 2. Oop. Alright, so now we have all the operations that we can do with big decimals, the key ones at least. And let's print out results. System out print line. The sum is plus decimal or sum dot toString. And we have to use this toString method here to convert the big decimal sum into a string so we can display it in the console. So we're concatenating these two strings and passing that to the print line method of the system output stream. We do the same thing. To make this easier, subtract difference plus subtraction dot toString system out print line. And did I miss something there? No, that looks right. Okay. System out print line product plus product dot toString and quotient divide dot toString. Let's run that and see if it works. What am I doing here? What is up with my mouse? It's acting all freaky on me. Let me fix that real quick. Okay, there we go. Let's run that. The sum is 15, the difference is 5, the product is 50, and the quotient is 2. So that worked exactly the way we would have hoped it would. You'll notice that the product has 2 extra decimal places. That's because we multiplied something with 2 decimal places with another thing that had to do 2 decimal places. So Java took that and it actually ends up multiplying those, and it comes out to be 4 decimal places. Now with the quotient we divided, so it did the opposite. It actually got rid of the 2 decimal places that were on. Okay, so the next thing I want to show you is how we can do big decimal operations by changing the reference of the big decimal. So let's say we have a big decimal and we want to or we have decimal 1 and we want to set decimal 1 equal to 15 instead of being equal to 10. What we had to do before was create a new big decimal called a sum decimal, and we would just use the add method to add decimal 1 to decimal 2. So that's what we just did. Now what we can also do, DECIM1, decimal 1 is equal to decimal 1 dot add decimal 2. And as I said before, the value of a big decimal cannot be changed, so that just means that yes, we created this new big decimal with a value of 10. So decimal 1 is referring to this new big decimal object with a value of 10. Now, that value of that big decimal is always going to be 10, so how come we can add these together and make decimal 1 equal 15? And let me just show you that. Print line decimal 1 is plus decimal 1 dot to string, and with semicolon. Alright, so now we have decimal 1 is 15. So it looks like I just changed the value of decimal 1, but really what I did was we created a brand new big decimal which is equal to the original big decimal, decimal 1, plus decimal 2, and then we assigned that reference to that new big decimal. So now decimal 1 is not referring to this original big decimal with a value of 10, but instead it's referring to an entirely new big decimal with a value of 15. And I have a diagram here to kind of illustrate what is going on there. So in this example, I have big decimal sum decimal equals new big decimal with a value of 14. And then we have this other decimal, which is a new big decimal with a value of 6. And I have up here, it says variable a sum decimal. So sum decimal is a referencing object a, which is the big decimal with the value of 14, and sum decimal, the other decimal, is referencing this object b, which is a second big decimal with a value of 6. And then when we set sum decimal equals sum decimal dot add other decimal, we are changing the reference of the first variable. So the variable a sum decimal is actually now referencing this new object c, which has the value of the combined sum. So in this case it would be 20, because 14 and 6 is 20. So this new object c down here has the value of 20, and variable a is no longer referencing this object a. So we never changed the value of object a, but instead we created this new object c with the different value. So like I said, big decimals are still immutable, and we did not change the value of the big decimal directly, but we merely changed the reference to what the decimal 1 identifier variable is referencing. So that is what I mean when I say that when I'm talking about references here. Okay, so I hope you understood that. It's kind of a more abstract concept than what we've done so far, but I hope that diagram helped. Have any questions about that? Be sure to let me know. Now the next thing we're going to talk about is creating new big decimals within a... Actually, the next thing I'd like to talk about, I suppose, is printing the results out. And we can print out the results, like I said before, when we multiply. So let's change this to multiply. So decimal 1 equals decimal 1 dot multiply decimal 2. Run that. And now we have these extra zeros in there. So one way we can get rid of those zeros is to use the format specifier and convert the big decimal into a double. So double my double equals decimal 1 dot double value, and this double value method will convert the value of the decimal into a double, and then we can say that it is now in a double. So system out.printf, the double is %d, comma, or is that actually %f that I'm looking for, I believe. So %f my double. We run that. the double is, and of course it's going to add even more zeros onto there because now it's a double. But we can control that using the format specifier and putting 0.2 in there. And now we have the double is 50.00. Oh, my dog shut up. You want to take a look at her? Suki, come here. Come here. This is my dog Suki. She's a good girl and I love her very much. Mwah. Alright. On to the next topic of discussion. So we are going to learn how to set scale to control rounding. Okay? So let's actually not leave that, but let me just kind of go back. Oh, la la la. Okay, there we go. So now I'm back to printing out decimal 1 as decimal 1.2 string. So we run that, and we have 50.0000. Now where is the rounding section here? Okay, setting scale to control rounding. So in addition to being able to control the amount of decimal places in BigDecimals by converting them to doubles, you can also use the BigDecimals set scale method. And this is the preferred way to do it because it gives you control over exactly how your decimals will be rounded in calculations and things like that. After creating your big decimal, you can use the set scale method to define the amount of decimal places you would like the big decimal to go to. In most cases with currency, of course, we're going to be rounding to a value of 2 decimal places. And the format for creating a new big decimal with a set scale is as follows. And let me try to zoom in here so you can see a little better. Okay, here we go. So big decimal sum decimal equals new big decimal with the value that we give it. And then we add dot set scale, the scale, and the rounding mode. And there are a few different rounding modes that we can use. Big decimal round ceiling, and that rounds to the next highest number. Round down, which rounds in the direction of 0. Round to floor, which rounds to the next lowest number. Round half up, so that means if the decimal is greater than or equal to 5, we round up, and in the example here we have 1.225 becomes 1.23, and 1.224 becomes 1.22, so that's rounding half up. And then we have round half down, which does the opposite, so 1.225 becomes 1.22, and 1.226 becomes 1.23. So let's look at the example that I have laid out here. So we have big decimal, sum decimal, equals new big decimal with a value of 14.555. Then we set the scale to 2, so that means we are going to have 2 decimal places in there. And we put a comma in for the next parameter, and we use big decimal dot round half up. So that is where, like I said, where we round half up, so 1.225 becomes 1.23. So the 5 is rounded up to a 3, and then in the case of 1.224, it would be rounded down to 1.22. And this is probably the most common one that you'll see, and it's what's typically taught, I think, in math classes and things. You round up at 5 and down at 4. So that's the one I used for my example here. And then we printed out the value of sum decimal is sum decimal.toString. And the output of that would be the value of sum decimal is 14.56. So it rounded that 5 up to a 6, and it got rid of the last decimal place. And the next thing we're going to talk about with big decimals, I apologize, this is kind of a long lesson, is unreferenced objects with big decimals. And the good thing about unreferenced objects is they allow us to multiply and add things to big decimals without needing to write out actual variable names. So let's say we have decimal 1 and we want to add 5 to it, but we don't want to have to create that decimal 2 in there. We can do this by doing decimal 1 equals decimal 1 dot add, and in here in the arguments parameters we can do new big decimal with the value of 5.00. So what I did there was, instead of creating the new big decimal up here and giving it an identifier and a name and whatnot, all I did was I created the new big decimal directly in the parameters or arguments for that method. And that way we don't have to give it a name and worry about that. So this is going to create an entirely new big decimal with the result of the first decimal and this new second decimal added together. And we do system print line, and I'll just do decimal1.toString. Let's run that. And as you can see, it is now 15. So that is how we can use unreferenced objects. Of course, we can do that as many times as we want. So decimal1 equals decimal1.multiply. And we can do new big decimal. And let's multiply that by 2. And we'll print that out again. So now it's going to take that 15 and multiply it by 2. So now we have 15, and now we have 30. So at this point, it's equal to 15. And this point, the value is 30. So that's how we can use unreferenced objects with our big decimals. Definitely a very, very useful thing to be able to do. All right, finally on to the last topic of this section. I know you probably thought it was never going to come, but alas, here it is. So we are going to talk about scanners with big decimals. So let me just bring up the thing here. It's important to understand how to get user input and store it as a big decimal. This method works quite similarly to how it did in the previous lesson. The example below demonstrates how you can ask a user to give you a monetary value and then print that value to the screen. So we import the big decimal and the scanner from the Java API. We create the new scanner the same way we did before. Scanner user input equals new scanner system.in. We ask the user for a value, so system.out.println enter some monetary value. Big decimal number entered equals user input.next big decimal. So this is the key here. Next big decimal will take the next value that they enter, and it'll throw that into a new big decimal, which is going to be the numbered enter. And then of course we have to close the scanner, and we can print out the result. So let's try that. Let me just copy that here. Copy, right click copy. Keep forgetting I'm in a virtual machine here. Okay, and let's paste that. I have to import the scanner because I didn't do that yet. Alright, so we run that, enter some monetary value, 10.10. The value of number entered is 10.10. So that is how we can control or include a scanner and use that to store the results in a big decimal. That is it for this topic. The review exercise here is to create a program using big decimals that calculates a sales tax. I'm in Pennsylvania, so I chose 6%. You can use whatever percent you want, but for my demo, I do 6%. So we're going to have a program where we enter the item price, we store that value in a big decimal, and we calculate the sales tax in another big decimal, and then we get the total price of that sale we add the sales tax and the item price together, and we print out the total price of that item. So that is a pretty easy program there. The solution is of course down here, and you can watch the video by clicking the watch video button. So I do have a full guide on how to do that. Thanks for watching and take care. Next lesson we are going to be talking about decision making, so that's going to be a lot of fun.